This video is going to cover questions from section 2.2 from the practice of statistics. I'm specifically going to be looking at 43, 47, 49, I skipped 45, 43, 45, 47, 49, 51, and 67. Number 43 actually went with exercise 41. So I looked back up at exercise 41 and I labeled these, the curve, like sketched the curve here. This is a normal distribution. It's approximately normal with a mean of 69 and then a standard deviation of 2.5. I don't know where that came from, 2.5. So I think most people didn't really have problems with the first couple questions. It seemed like it was part C that was the issue, but I'll go ahead and go over these real quick. Between what heights does the middle 95% fall? That would be between 64 and 74, because between these two is 68%. Between these two is 95%. And then between the next two would be 99.7. So this was 64 and 74. What percent are taller than 74 inches? Well, if we know that this middle part is 95%, then that means that this tail right here and this tail that I just colored in yellow has to add up to 5%, because 100 minus 95 is 5. But these are two tails and they're symmetrical, so I would need to do 5 divided by 2 to get what this percentage is. This percentage is 2.5. So the percent of men that are taller than 74 would be 2.5%. All right, now for the question that people seem to really have was, what percent of men are between 64 and 66.5? So that would be just this part, between 64 and 66.5. So personally, I notice that is like between 95 and 68, like that's the bar that's kind of in between those two areas. So if I do, let me switch to a pen. If I do 95 minus 68, that's going to tell me how much area is in both of these sections. Okay, so both of those yellow sections down there would be 95 minus 68. That gives me 27. Now if I want just how much the area is in one of those, I would need to do 27 divided by 2, and that would give me 13.5%. Then the last one is a height of 71.5 corresponds to what percentile of adult male American heights? So, there's a couple different ways to do this. I like sometimes to consider the fact that the mean always lies in the middle. So that would mean that, and I know this is getting really messy, hopefully you can follow. From here over is 50%. Okay, so all this is 50%. Because the middle section is 68%, I know that this one is 34. So if I wanted to find from 71 to 71.5 over to the left, I would do 50 plus 34 and I get 84%. So since there's 84% below it, that would mean that a man that's the height of 71.5 would be in the 84th percentile. This one's kind of fun, though you're probably not going to have to do this on a test or something, but one thing that's kind of interesting about the standard deviation is that one standard deviation away is generally where the curve changes from concave down to concave up. Like you're kind of looking for where that change happens. So I'm going to look at the purple curve first because I feel like it's easier. I'm going to trace it I'm going to start at 0 and try to trace with my pen. So right around here, I feel like I was curving down and then all of a sudden I was curving up. So I don't know, that's like maybe about right here-ish. So I would guess like 0.5 to be the standard deviation for the purple curve. because again, I'm kind of trying to see where it was curving down and then where it was curving up, like right in the middle. That's called a point of inflection or an inflection point. If you've taken calculus, then you are very familiar with that. But that's the inflection point. For the red curve, it's going to be a little bit harder. So I'm following, I feel like I'm curving down. It's really hard to tell. I think maybe about here-ish is where it kind of changes from curving down to curving up. And so that's probably about 0.2. Truthfully, I wish I had taken this question off of your homework. However, I didn't decide that I was not going to focus on the table until after I had already assigned everything. But you are totally able to do these questions using either a Staplet or your calculator. So don't stress about it too much. But I'll go ahead and show you how to do it. So there's this table, this page that I just took a picture of, comes from the back of your book from page T2. Okay, there's like T1 and T2 is table A, and it's in the very back of your book. So this is 2.85 for the z-score. Now, all of these values are going to be giving you the area to the left of the value. So within the table, it's going to be giving you the area to the left. Part A asks you for the area to the left of 2.85. So I go to 2.8. Okay, notice I'm highlighting in green. That's the line for 2.8. And it's 2.85. So I'm going to go up here where it has 5 and then go down. And then right there in the middle where they hit each other, 0.9978, that is the area for part A. So 0.9978 is the area to the left of 2.85 standard deviations. Now part B is actually asking for the area to the right. Now wouldn't it stand to reason that okay, this is probably where I'm looking at. Pictures are helpful. Let's say that this is about 2.85 standard deviations away from the mean. And all that area to the left is 0.9978. If I want the area to the right, then I need to do 1 minus 0.9978. And that will give me the answer for part B, because it wanted to know what was greater. That is 0.0022. Okay, to do C and D, I'm going to have to flip over to the negative side of this table on page T1. It starts off by wanting to know the area to the right of negative 1.66. So I'm going to have to first find the area to the left. I'll use the green highlighter again. So negative 1.66. So I'm going to go to negative 1.6. for my row. Since it was 0.66, I'm going to go down this column. And then this number right there that's in the crosshairs, that's the percentage to the left. So if I want the percentage to the right, I'm going to have to do 1 minus 0.0485. Because remember, the table always gives you the area to the left. The reason I know I want the area to the right is because that was a greater than sign in part C. So when I subtract those, I get 0.9515. Okay, and then D, I'm going to have to combine what I know. So let's look at this little tiny picture I made up here of the normal curve. If that area, that yellow area, is the area that's to the left of 2.85, and let's say this is about negative 1.66. This is the area to the left of negative 1.66. If I want Z to be in between those two, that means I'm looking for this middle part. So I need to do the yellow area minus the black shaded area. So it's going to be 0.9978 minus 0.0485. and I get 0.9493. I definitely wouldn't worry about this too much because you're going to be able to use your calculator or a Statlet to help you out. Okay, y'all, I'm going to be honest. I skipped number 49 because I just did one with the table, and so it's the same thing. It's the same process. 51, it wants you to use the table but work backwards. So this time it's giving you a percent and you're having to find the z-score. So these are particularly annoying, and it's way easier to find the answer and way more accurate to use a calculator or the Statlet. So I am going to show you how to do it though, and then I would like you to kind of look at the Statlet for how you would do it. So I have to actually look at these values in here and see which one looks closest to 10%. So that would be 0.10. I notice right here, do you see that 0.1003? That's the closest number to the 10th percentile. So if I follow the rows and the columns, then I can see that z must be negative 1.28. Because on the left side I see the negative 1.2, and then on the top I see the 0.08. So that would be negative 1.28. Okay, for part B, I decided to use the Statlet, except I could not get the Statlet to work correctly on my iPad. So this said, find what's the z-score for 34% of observations that are greater than z? I had to do less than z just because it wouldn't let me change this left tail. So I changed the Statlet so that it was giving me typing in an area, and then the boundary was 0.34. Now, obviously, this gives me a negative z-score, negative 0.412. But if I wanted to do the one that was greater, the nice thing is at least it's symmetrical, right? So for the one that's greater than the 34% is like the right tail, the z-score is going to be positive 0.412. Number 67. We collected data on the tuition charged by colleges and universities in Michigan. Here are some numerical summaries for the data. Based on the relationship between the mean, standard deviation, minimum, and maximum, is it reasonable to believe that the distribution of Michigan tuitions is approximately normal? Explain. So what I noticed right away is this is the standard deviation. 1873 is not, if I subtract one standard deviation, or maybe, you know what, let's find z-scores. I'm going to find the z-score of the minimum and the maximum. So if it was approximately normal, I would expect the minimum to be 2 or 3 standard deviations away from the mean. So I do the value minus the mean divided by the standard deviation, and that gives me negative 1.09. So the minimum is only like a little more than 1 standard deviation away. But the maximum, if I find its z-score, it is much farther away. Hold on. It's about 2.51. So clearly the maximum is a lot farther away than the minimum is from the mean. So to me that sounds like it's probably skewed. It's probably piled up on the left side and then stretches out on the right side. So I would say no, this is not approximately normal.